All right, so I just wanted to kind of like go over some basic concepts with triangles. These are things, ancient Egyptians knew figured out about, and this will definitely help you in physics. It makes it so we can solve more interesting problems. Um, it's if we don't have any angles at all, it's just I don't know. I'm sorry, it's just not that much fun. But thankfully, these rules are very simple. Um, so you probably already know them, to be honest. If you have a right triangle, and this angle is 30 degrees, okay, and this angle is 60 degrees. I think my dad taught me this in like middle school, so it's kind of cool. The ratio of the sides has to be the same. So we could make this triangle larger, smaller. It doesn't really matter. The shortest side and the longest side, I know the shortest side because the shortest side is opposite the smallest angle. So this has to be my shortest side, right? So the shortest side and the longest side are in the ratio of 2 to 1. So the longer side is twice as long as the shortest side. And the longest side has to be opposite the right angle because the right angle is the biggest angle. So the longest side is opposite the largest angle. Okay? So the short and the long side follow a ratio of 1 to 2 or 2 to 1, depending on how you look at it. Longer side is twice as long as the shortest side. Shortest side is half as large as the longest side. Okay? And then the other side is like radical 3 larger than the shortest side. Okay? So it's like counting 1, 2, 3, right? Except it's 1, 2, radical 3. And, I wouldn't mind if you put this on a note card ever. For tests. I don't want you to memorize stuff, but it's just easy to remember. It's just 1, 2, radical 3. Okay? And radical 3 is the medium length side. That's the side opposite the 60-degree angle. Because radical 3, if it was radical 4, it would be 2. So it's smaller than the hypotenuse. And if it was square root of 1, it would be 1. So square root of 3 is a number between 1 and 2. It's probably like 1.7 or something. You can put it in a calculator if you really want. But some number times itself, right? So square root of 3. Okay? So some number times itself will yield 3. And I think it's 1.7 something. Anyway, so that's one triangle you got to know. It's called a 30, 60, 90 right triangle, and you can see why, right? And then the other one I'd like you to be able to work with, let's see if I can draw it. A right triangle. Oh, that was terrible. Let's make the right triangle part first. There, this is going to work. Oh, that's kind of cool. I like that one. Haha. Now, let's say, now I'm just trying to think of the simpler ones. 45 degrees, let's say. So that means that two sides are identical, okay? And the long side, the hypotenuse, obviously is longer than the other two sides, okay? So I'm going to call these sides 1. And then if you count 1 to 2, right? Except the hypotenuse is going to be radical 2. So it's just a little bit larger than the other side. So on a 45-45 right triangle, the two equal length sides are the same length, obviously. And the longest side, the hypotenuse, is a length of radical 2 larger. So it's just a little bit larger, okay? Radical 2 times larger to be exact. The nice things about radicals is they're exact numbers. They're very precise. You don't have to turn it into a decimal or anything like that, because radical 2 is a beautiful, precise number as it is. Anyway, I hope that helps. Those are the two things I'd like you to know, the triangles, and you can sketch them on a note card if you want. You don't have to memorize them, but knowing that is just going to be able to they'll help you be able to solve more interesting things rather than just the standard physics problems. You can just do a little bit more, have a little bit more fun with the physics. All right, so I hope that helps, and have a good day. Thanks for watching the 2-minute and 10-second screencast.